So we're going to be looking at electrolytic cell. So what do we mean by an electrolytic cell? This is an electrochemical cell where we have electrical energy driving a non-spontaneous redox chemical reaction. So we have a few expressions that we have to clarify. Electrochemical means that it has both electricity and chemical reactions. It's a reaction that has both electrical properties and chemical properties. So this is an electrochemical cell where we have electrical energy, which is normally the source of battery, the form of a battery. Sometimes you'll have the battery looking like this, or you'll see lines like these. The longer line normally represents the positive pole, and the shorter line represents the negative pole. So, so we're going to be looking at our electrolytic cell. So here we have a simple arrangement. We have a container. In this container, we have two electrodes. We have our anode and our cathode. Our anode is connected to the positive portion of the battery, and the cathode is connected to the negative portion of the battery. Here we have molten lead 2 bromide. The word molten means that it's just liquefied. It's in the liquefied state or it's melted. So this is the purpose of we applying heat here. We're applying heat to ensure that this lead 2 bromide maintains the liquid state. It doesn't become solid. We don't want it to become solid because we want free flowing ions. So inside this lead 2 bromide, these are the available ions we have. We have lead, Pb2 plus, and we have bromide. Okay, the positive end of the battery is what's pulling, will cause electrons to drift towards this portion. This positive portion will pull electrons here. The negative portion will push electron. So it's the lead 2 bromide is going to behave in a way that it would normally behave. Right? So we have here, let's take a look at what's taking place at each end. At the anode. The anode is a positive pole here for this cell. It's not the same for a galvanic cell. It's actually the opposite. So in an electrolytic cell, the positive portion is the anode. And we know at the anode, we always have oxidation taking place. That's the loss of electrons. So if we're, and that's the positive pole, so the positive pole will be pulling electrons towards themselves. So these electrons are pulled away. So we have our bromide ion in the liquid state is going to return to bromine gas. But this is actually a two-step process. We have the bromide losing electron, and we have a bromine atom, and two bromine atoms combine to give our bromine molecule, and these bubbles here represent the bromine gas. So if we look back at our diagram, when we are seeing these bubbles here, what we're actually seeing is bromine gas being given off at the anode. Okay, let's take a look at what takes place at the cathode. At the cathode, that's the negative pole. So we have electrons being pushed into the electrode. We have the we have the lead ion gaining electron and forming lead in the liquid state. So this liquid, these dots here, red dots, represents bromine in the liquid state. So we have a deposit of bromine in liquid state here. So it's pretty simple when we have molten substance. We have molten lead 2 bromide. This is going to break up into lead 2 plus and bromide minus. If I gave you, let's say I gave you molten silver chloride. We would have the available ions we would have would be silver and chloride. So the chloride will be deposited at the anode. So we'll have chlorine gas being given off, and in this case we'd have silver being deposited here. So when we have molten, that's the liquefied version, we can clearly tell what's going to be deposited by looking at the available ions. We only have silver and chloride. It's a bit different when we have something in the aqueous state. So let's examine the electrolysis of brine. This is a very popular electrolysis. Brine is salt water. So we have sodium chloride, that's our salt in the presence of water. What we have is we have sodium ions, chloride ions. The water will also produce H plus and OH minus. So here we have a lot of ions. So we're going to have actually have a competition in some cases. So this is just typical arrangement for electrolysis of brine. We have the brine coming inside here. This portion, the positive portion here, would be our anode, and this is our cathode. And we have what we realized that we could take out sodium hydroxide. This is where inputting water, and depleted brine comes here. So let's look closely at what takes place at the anode and what takes place at the cathode. So at the anode, that's a positive pole, we always have oxidation taking place at the anode, and oxidation is the loss of electrons. At the anode, the chlorine ion lose electrons more easily than the other ions present. Because remember, we have quite a few ions here, but the chlorine is the one that loses the electron most easily. So the chlorine will win the competition here, just as they did in electrolysis of molten rocks. If we have just salt, molten salt, so we'll have the chlorine being deposited. So this chlorine forms chlorine gas, and we use this chlorine gas in our production of PVC. That's plastic pipes. Alright, so let's look at the equations here. We have the chloride losing an electron. They combine together to form chlorine molecule, and we see that chlorine gas is given off here. Now at the cathode, the reaction that occurs is different than in the molten state. So here the H plus is actually the one that is easier to be reduced. So we're going to have H plus ions being the one that is going to be reduced. It's going to gain electron. So H plus is going to gain electron, and we're going to have hydrogen gas being evolved. Right? The available ions, the overall change is sodium chloride and water. We're going to have chlorine gas being given off, hydrogen gas being given off, and we also have sodium hydroxide form. Because remember, we have the Na plus and we have OH minus, which was not used before. These will combine to form the sodium hydroxide. So this was the unused sodium plus and the OH minus. They are going to combine to give our sodium hydroxide. The NH plus and the OH minus, which was not used up, is going to combine to give our sodium hydroxide. So that's how we have the sodium hydroxide being given off. I hope this helps.